All right, welcome back, chemistry fans. Today, what we're going to do is twofold. We're going to get 2-for-1. We're going to do a solubility test with 2 different chemicals. And then the winner of that, the one that actually does have solubility that will dissolve in water, well, then we're going to do some calculations on a percent mass. And then we're going to compare that to its absorbance, and we're going to see the relationship there. We've already kind of done this whenever we saw Beer's law, but we're doing it with a different formula this time. All right, so let's get started on the problem. Okay, so we will flip the camera around so that you can see what we're working on now. So we've got the surface right here. Let's adjust that now. Okay, so what we've got down here, the 2 chemicals we're going to be working with today, it is calcium chloride. Let's see if that helps it any. Not really. Calcium chloride and sodium phosphate. Calcium chloride, sodium phosphate. Well, one's green and one is white, but that's not indicative necessarily of anything, information that we need. All right, so let's first take 1 gram. So let's weigh out 1 gram of both of these here. And the 1 gram is nothing specific. We're just kind of getting a starting point of so we can have the similar measurement amounts. And what we're going to do also is we're going to dissolve this into 50 milliliters of water. So I've got my measured 50 milliliters of water right beside me. I'm going to tare the weight there. So let me bring my camera so you can see it's not weighing anything. And we're going to put in 1 gram of the sodium phosphate, the white powder. So there we go. Oh, I'm in ounces. Hold on. Let me switch over to grams. 0.7, 0.82, 1 gram. Oh, man, exactly well, it's close now. So I'm going to put that into my container here of water. And I'm going to stir, stir, stir. And I'm going to stir, stir, stir. And I'm going to stir, stir, stir. And nothing happened. As you can see down on the bottom, it's sitting there. That is an indication that no matter what we do, this is insoluble in water. So this is one of those polarity moments where it is not going to dissolve no matter what we do. Water and this material seem to have opposite polarities. They will not mix. All right, so we're going to dump this guy out, and then we're going to move to our second material, which is the green. And let's see if we can get 1 gram of each one of those in here. Oh, and let me put 50 mils of water into this. We're going to get 50 mils of the copper chloride. And again, oh, let me clean out my weighing boat here so that we can get our weight on here. I'm just rinsing and drying. That's the sound you're hearing. So let me put this closer to you. So now my boat weighs nothing. We're going to put 1 gram in. And there's your 1 gram. Okay, so I'm going to put that into my 50 milliliters of water. And what you should see is after we stir it, that we get a different response. It has completely dissolved. All right, so I'm going to write down, I've got my first material, and I put in 1 gram of copper chloride for every 50 milliliters of water. Okay. So what is that going to do? Well, you're going to have to calculate a mass percent of that. Mass percent is simply the mass on top, mass of the solute, divided by total mass of the solution. Now, here's the nice thing. 50 milliliters equals 50 grams. So what's going to be our total mass underneath? Should be somewhere in the 51 range. All right, so now I've got this. What we're going to do next is we're actually going to combine this with what we already know about the absorbance factor from Beer's law. So we're going to fill up one of our crucibles, cuvettes rather. We're going to fill up one of our cuvettes with this solution here. We're going to cap it. Now I have already I have already zeroed out my my response. So here is my blank that I'm putting in. And what you should notice is the absorbance is at 0. And notice that my my value over here, I'm on the farthest side at 430 measuring the blue stuff, because that's basically what we have with this solution. And so what we're going to do is we're going to slide open the door, we're going to remove the blank, and we are going to put in our good material, and we should see a different value coming off for it. But maybe what we will do is we will... Okay, so what you notice is my first value on this solution, it's 0.22. So we're just going to take that value, that's my absorbance of 0.22. All right, now let's make a second solution. So I'm going to take out this current solution, put it off to the side, and I'm going to make a second solution this time with a new amount of copper chloride. So I'm going to put this off to the side. Going to get my weighing boat on here. Weighing boat is on, and it's at 0. So this time I'm going to put 2 grams of the copper chloride. 1.5. That's close enough. That's pretty close. That's about 2 grams. 1.97. So I will write that down. 1.97 for my second solution. I'm going to dump out my original solution, rinse it out, start over again with 50 mils of water. So I've got my 50 mils of water, and I'm going to now dissolve this in. We know it's soluble. We know it will dissolve. We hope that what we see is a little bit darker solution. And we already know from Beer's law that what we're seeing is this parallel direct relationship. We'll see how direct it is. So I've got now my second solution, and I've got my second cuvette. So I'm now going to suck up some amount of this cuvette and to put it into this cuvette. And let's go ahead and put it into our colorimeter so that we can start to measure and see where it falls. Boop. Let's see. It went to sleep. And as expected, what we see is a 0.42 value, 0.41. So for our second one, 0.41 absorbance. All right, so we're starting to see some relationships here. And then finally, our last concentration. Oh, and that again was in 50 mils. And so for our third and final, so that we can make a line out of this one, what we're going to do is we are going to make 3 grams. Woo, we're just going to push this up to the next level. So I'm going to get my balance, put my weighing boat on here, and we're going to get 3 grams this time, or whatever we get, what we measure. .86. That sounds pretty doggone close. All right. So we're going to take that, and we're going to put it into our water beaker of 50 milliliters that I have measured. We're going to put that in there. And now we're going to get rid of the balance. We don't need it anymore. We're going to stir. And notice it still is dissolving. The color is getting a little bit more blue, as expected when we have a higher concentration. So we're going to fill up. And we are going to, boop, we're going to put in this. Now let's see what our absorbance is for the third value. So we take out the second. We put in the third, close the door. And as expected, we are seeing the correct results, 0.89 absorbance. Okay. So now I have all of my data. That was 2.86 grams over the same 50 milliliters. And so what we're going to do is we are going to create a graph. We are going to plot our absorbance versus our mass percent. And the hope is that we get some kind of a straight line between the 3 dots. So you are going to plot those on your Google Sheets. All right, this is everything that I wish for you to accomplish today. Thank you very much. Let me turn the camera around so I can salute and say farewell. All right, Thank you very much for paying attention. I hope that you've learned a little bit more about your solution chemistry. All right, talk to you soon. Bye-bye.